In this video, we're talking about something called linear applications. Now, one of the most common questions that students in particular, ask about math is, when am I ever going to use this in real life? And then you roll out some word problems and everybody moans and groans and acts like they're going to die. So here's the problem. Word problems are actually applications of algebra in the real world. So we can't kind of have it both ways. So if you want to know how algebra is used in the real world, we actually have to use word problems. No worries, we'll walk through it. So linear applications and word problems are the same thing. It's how algebra is used in the real world. So basically, it's helpful to choose a letter that corresponds to the word in the problem as the variable. So if I'm looking for length, use L. If I'm looking for width, use the letter W. If I want to use miles, use the letter M to kind of help you keep track of what you're doing in the algebra problem. Later, you will be creating your own algebra equations from the word problem, and so that becomes more important. Right now, we're sort of limiting some of the algebra that you'll be doing, so a lot of it's going to be kind of set up for you. Remember to include units in your answer. In other words, you're answering a word problem with words. So if you go into the carpet store and you ask the guy, hey, I need 250 of carpet. Well, 250 of what? 250 yards, square yards, 250 square feet, 250 square meters. What are we looking for here? It's not going to help you if you don't know what the units are, okay? Or if you get a bill in the mail and it says 24. Well, 24 what? 24 cents, $24, $240, 24,000. There's a big difference here. So make sure you use your units in your answer. Also, check your answer in the equation to confirm that it is correct. So we have two main kinds of problems that we're starting off with. The first kind of problem has to do with like car rentals or maybe electricity bills where you have like a monthly rate plus, you have to pay a certain amount each month, or on your cell phone, for example, plus maybe extra for data usage that you use, or plus extra electricity that you use, that kind of thing, where you have like a base rate and then you add a particular rate based on how much you use or how many miles you drive or whatever. So that's the first sort of problem that we have. The second problem that we're going to talk about is a perimeter type problem, where you have a rectangle. It's always a rectangle right now, and you want to solve for the dimensions of this rectangle, okay, of this garden or this basketball court or whatever this rectangle might be. This lesson is based on Blitzer's Introductory Algebra for college students. Okay. So here, the first example talks about charging $125 just to rent the car, okay, maybe for the week or whatever. But then you also get charged for the miles that you put on the car. So we want to know how many miles you can travel. So this budget, or this formula, says the total amount that you're going to be charged when you walk in the door is going to include the $125 that you have to pay just to rent it, plus 20 cents for each mile that you drive it. So if you drive more miles, it goes up. If you drive less miles, it goes down, okay? So this is used, again, in everyday life, and this is algebra. People say, oh, when am I ever going to use algebra? Guess what? If you've ever rented a car, you're using algebra. Okay, so the total amount that this person has is $335. So that's $335 is equal to her first $125 that you spend is just to have the car. If you don't even drive it off the lot, but you have the key for the week in your pocket, then you're paying $125, period, plus 20 cents per mile. The question is, how many miles? We want to answer the question, can you travel on this budget? Well, the first thing I need to do, because pretend that this were an X. If this were an X, what would we do? We'd get rid of the 125 first. So we subtract 125 from both sides. Okay, when we do that, we get 210 is equal to 0.2 M. Now, don't let the decimal freak you out. It's okay that the decimal is a decimal and not like a 2 or a 5 or a -3. It's okay. Doesn't matter. Since 0.2 is being multiplied by the number or by the variable, to get rid of it, we divide. And guess what? Every calculator can divide by a decimal, so it's not a problem. Okay? So we end up getting 1,050 is equal to M. I don't really like writing it this way. It's kind of backwards. So M is 1050. What is M? What was M? What was that? Well, what were they asking? The question is, how many miles can you drive? Well, the answer is 1,050 miles. My answer needs to have the unit in it. Otherwise, it means nothing. Okay? All right. So I want you to try this practice problem. Using the same kind of concept that we just used, here is the answer. Total cost to drive a taxi or ride in a taxi. And that's how many miles. Oh, I forgot to check this one. Let's go back up and check this one. So if you went back in and said 125 plus 0.2 times 1050, here's my check, plus 0.2 times 1050, okay? You put this in your calculator, guess what you would get? 335. Does this 335 match the total cost? Yes, that's why you check it. Similarly, whenever you got that your taxi, you can go 4 miles. You substitute it back in to the right side of the equation and see if your answer matches the left side of the equation that you were told. Okay, let's do the next one. This is the type of problem where you have a rectangle. Now, here is the key for these problems. The problems need to be written in terms of only L or only W, only the length or only the width. And the reason for that is that you can only solve for one variable. Over here, you only had one thing that you didn't know. That was the miles. Over here, you have 2 things that you don't know. They're asking for the length and they're asking for the width. How are you going to solve for 2 things? Okay, that's pretty tough. So the way to do it is to solve for one of them and then solve for the other. The problem is they're both in the same equation, but it does give you information about one. A rectangular soccer field is twice as long as it is wide. So you know what most people put? Twice as long as wide. Well, guess what? That's wrong. It's actually this way. Let me tell you why. Let's pretend that this soccer field was 10 yards and 5 yards. Remember that the length is always more than the width. The dimension that's longer is called the length. The dimension that is shorter is called the width. So this is not the correct answer. I'm just putting in fake numbers to prove to you that the second equation is correct. So it says the length is twice as long as the width, right? It's twice as long as it is wide. Twice as long as it is wide. Well, if I put in 2 times the length, if I put in 2 times 10 and said that that's equal to 5, what's wrong with this formula? 2 times 10 is 20, which is not equal to 5. Okay, let's try this one. 2 times 5, is that equal to 10? 2 widths equal to 10. Yeah, the length is longer than the width. So you have to double the width to get the length. Try not to stress out if this doesn't make a whole lot of sense, but the bottom line is when it tells you that the length is more, you have to do something to the width in order to be equal to the length. All right, how is this helpful? Well, since the perimeter is known, it's 300 yards, so I'm putting in 300 in for P. 2 L's. Well, L's is 2 W's, right? Every L is 2 W's. Every L is 2 W's. And then I'm going to add 2 more W's because this is part of this and this is part of this. You're going to substitute it in. It's sort of like when we evaluated equations. So I have 300 is equal to 4W because I multiply 2 times 2 is 4 plus 2 W's. I don't need to distribute the 2 because everything is just 2 times 2 times W. It's not 2 times 2 plus W. It's just 2 times 2 times W. 4 W's and 2 W's give me 6 W's. I'm going to put them on the left because I want to have my W on the left. Okay. Now, I have a width. How do I find the length? My length is twice my width. So my length is twice my width. Now I need to check it. perimeter is 2 times my length plus 2 times my width. 2 times 100 is 200. 2 times 50 is 100. Is 300 my perimeter? Yes, so it's correct. So that means my width is 50 yards and my length is 100 yards. So my answer is the dimensions of the soccer field are 50 yards by 100 yards. Now the trick in this one is to write my length formula or my length equation related to my width. Here it says a rectangular swimming pool is 3 times as long as it is wide. The long is a bigger number. So my length is 3 times my width. Because if my width were 10, my length would have to be 30, right? The length is longer than the width. So it's always, you're always going to be manipulating the W to make the length longer if it's longer. So we substitute that in. The perimeter is 320 feet. 2 times my length plus 2 times my W. Try it out. Hopefully this is what you got. Remember to go back and check. All right, well, we'll see you next time for Graphing Linear Inequalities, section 2.7.